Okay, so the second question on our second midterm was a question about a drone flying around in circular motion around a soccer stadium. And we're told the angular displacement in radians of the drone as a function of time is given by a particular expression. And we're asked to find what the angular velocity of the drone at a particular time is. So this type of question is actually asking us to do some calculus and recognize that angular velocity is related to angular position as the derivative of the angular position with respect to time. And so if we substitute in our angular position, 2 plus 0.05t plus 0.1t squared, then this becomes a calculus problem. We use the distributive law to break this into derivatives of a constant. Derivative of a constant is 0. Plus, we can always take a constant out front of a derivative. Derivative of dt with respect to t is 1. And bring out our constant, the derivative of t squared with respect to t is something that we can do using the power rule. So this becomes 0.05 times 1 plus 0.1. And to take the derivative of a power, we take the exponent down and we lower the power by 1 from 2 to 1. And now we're asked to evaluate this angular velocity at a time t equals 2.5. So angular velocity at t equals 2.5 seconds is equal to 0.05 radians plus 2 times 0.1 is 0.2 times 2.5 seconds. 2.5 times 0.2 is 0.5, so this becomes 0.55 radians per second. So it's radians per second as well. And so we look at our answers, and that answer is there indeed. So again, angular velocity is the slope of an angular position versus time graph. And using calculus, we can use the distributive law and the power law to solve our derivative. Once we've done that, we have a function of time, and we can substitute in the time of 2.5 seconds into that function in order to solve for what our angular velocity is.